Okay, today we're going to talk about finding absolute max and min values. We'll start with, obviously, something is an absolute minimum if it is the smallest y value in that whole interval, if it is the smallest y value. If it is the biggest y value, it is the absolute max. Okay, so sometimes we won't have absolute maxes or mins, but what we're going to focus on today is maxes and mins over a closed interval. And this changes things up. So let's look at a picture. If I have a graph, I have a graph, and let's say we have something like this, okay? And let's say that x value is -1, and that x value we'll call 4. Okay, so I want to know between -1 and 4, what is the absolute max? And actually, let's only go over, I'm going to change this to 0. Between 0 and 4, so between here and here, okay? Between 0 and 4, what's my absolute max and my absolute min? Okay, the extreme value theorem says we have to have both an absolute max and an absolute min in that closed interval. Okay, so we can see the lowest point is down here. Okay, so that would be my minimum value. And the highest point, remember, we're going between these two dots. The highest point is up here, so that would be my maximum. When we close the interval off, you have to have both a max and a min, even if the whole graph does not have one of those. Okay, so even if we have something that looks like this, okay, that graph does not have an absolute max. However, if I close it off and I say between this spot and this spot, it does have a max, and the max would be right here. Okay, so we're going to talk about how to find the max and min over a closed interval, because we will always have both a max and a min when we close the interval off. Okay, so in order to find these, the places, and you might have noticed on those graphs on the last page, that there were two different places where maxes or mins happen. One was, and let's go back and look at that. One of the places is down here at the min, right? So one of them is at the critical values. The other one, and it happened both here and here, was at one of the endpoints. Okay, so those are the places that we're going to have to worry about. Endpoints and critical values are going to be the only places where we're going to have maxes or mins over this closed interval. Okay, so the first thing we're going to do is find the derivative. These are your steps. Okay, and then we're going to, once we do that, set it equal to 0 or does not exist to find out what they are, and then make sure whatever critical values you get, only use the ones that are in between the numbers given for your interval. If they fall outside, we can't use them because they're not part of the closed interval we're looking at. Okay, once you do that, you are going to make a list, meaning we're going to go old school. And when I make a list, I don't list it the way they do. I list it up and down. So I have my x values, and I have an endpoint, a critical value, the other endpoint, however many critical values you have in the middle. I list them this way. I go to my table of values. I get the y values. Okay. So the last step is to get all of these y values that go in this column. Okay. Whatever y value is the biggest, that's going to give you your absolute max. whatever y value is the smallest, that gives you your absolute min over this closed interval. Okay, so let's go ahead and look at that. So here we have one where we want to find the absolute max and absolute min of this function over the interval. Okay, so we want the maximum of this function over the interval from -2 to 3/2 or 1.5. Okay, so the first thing we need to do is find the derivative. So we have 3x squared minus 3. Okay, then we need to find the critical values. So 3x squared minus 3 equals 0. Divide out everything by 3, so we get x squared minus 1 equals 0. So x equals plus or minus 1. Okay, so our critical values are +1 and -1. Okay, we need to make our list. So we have x. All right, remember we need the endpoint, so that's -2 and 3/2. And then we have -1 and +1. And what you want to do is go to your calculator. And we just need to put each of these values into the calculator. So -2 gave me 0, -1 gives me 4, +1 gives me 0, and 3/2 gives me 0.875. Okay, so the biggest y value is right here. It's a 4. That means that's the max. The smallest y value is 0. That happens twice, so we're going to have a shared min. You won't often have a shared min, but for this example, we have 2 of them that are the same. So our max is -1, 4, and our mins are -2, 0. Remember, it's these values that are determining that, and 1, 0. Okay, it's always the y values that determine your max or your min. All right, and that is where we are ending for today.